Lesson 14 is linear inequalities in two variables, which just means inequalities with two variables, so x and y, or whatever our variables end up being. So 14.1 is modeling with two variable linear inequalities, and modeling is usually like a word that kind of means that we're going to be working with some word problems, some real life situations, and stuff like that. So example 1, it says the animal shelter rescues dogs and cats. The shelter can hold up to 125 animals. Write an inequality to represent the situation. Let D represent the number of dogs and C represent the number of cats. So they give us the variables to use in this case, so we're going to let D represent the number of dogs, and then C is going to represent the number of cats. So if we want the inequality to revolve around like the total number of animals, because it says that the shelter can hold up to 125 animals, that means that we're going to be adding the number of dogs and the number of cats. So we can start off our inequality by D, the number of dogs, plus C, the number of cats. And that's going to be in relation to 125. So it's like, it's not a total necessarily because it's an inequality, but it is going to have something to do with that 125. And then from there, we just have to figure out what does up to mean in terms of an inequality symbol. So does up to 125 mean that it can be more than 125? Does it mean it's like exactly 125? What does that mean in terms of an inequality? So up to means that, we can hold 125 or anything less than 125. So if we want to write the total number of dogs plus cats is less than, so we have like the arrow, not arrow, but the point of the inequality going to the dog plus cat. And then because up to means it like can be equal to 125 as well, we put the little or equal to line underneath. Okay, so this means the number of dogs plus the number of cats is less than or equal to 125. Up to means we can be 125 or anything less than it, so we use the less than or equal to. And then example 2, Tori rents a car that has a rental fee of at least $25 plus a daily fee of $18. Write a linear inequality in slope-intercept form to represent the total cost of the car Tori rents. Let D represent the number of days and T represent the total. So it says write a linear inequality in slope-intercept form. Slope-intercept form is y equals mx plus b. But they're telling us to use different variables here than x and y. So they're saying let D represent the number of days and T represent the total. So usually, not usually, almost always, our like number of days is independent versus like the total would depend on the number of days that she rents the car for. In other words, like how much she pays overall depends on how much she rents or how many days she rents for. So the total is going to be our dependent variable. And then the number of days is going to be our independent variable. And that's important. Hold on. Nope, I was about to spell it wrong. Independent. Okay, sorry. So that's important because it helps us decide what variables are being replaced in slope-intercept form, so like y versus x. So y is our dependent variable and x is our independent variable. So x is our independent, y is our dependent, and that means instead of using y equals mx plus b, we're going to use t equals m times d plus b. So x and y got switched out for d and t. Let's see, so d went in where x was right after the m, and then t went in where y was before the equal sign. And then, of course, since we're writing an inequality, we're not going to end up using an equal sign, but this is at least like now the form of our equation with the correct variables put in. Okay, so what I'm going to do is I'm just going to copy down like this little formula right here, and then we're going to make some changes to it depending on what our values are. So it'll be t, and then I'm going to put an equal sign there for now, but we're going to write an inequality, so that'll change. And then equals m d plus b. So when we write things in slope-intercept form, which this is, remember that m, slope, usually indicates like the change over time, rate of change, some sort of change. And then b is our like kind of one-time fee or charge, one-time something. It's like not a reoccurring charge. So if we read back through the information that we were given at the very beginning of the problem, so Tori rents a car that has a rental fee of at least $25 plus a daily fee of $18 per day. That $18 per day, that's changing each day that goes by. An additional $18 is being added. So that's going to be our M. And then that $25, the at least I know is kind of tricky, but the at least is more so telling us like what inequality symbol should be. So it's going to be $18 per day, and then that one-time fee of at least $25. So that's going to be our B. So if we take those and put them in their proper space, M is 18. That'll go right here. I'm just going to swap it out for 18. So 18D, which makes sense, $18 per day times day. And then for that one time of at least $25, so I'm going to swap out this B for $25. I'm just going to replace it in there. And then the last thing we need to figure out is what inequality symbol we're going to use. So I'm going to go ahead and erase the equal sign. Now we can go ahead and pick the inequality symbol. It'll go right here. So we have to go back to that word at least, which is, it's right here. I'm sorry, this is getting pretty cluttered. There's a bunch of like different things to point out, but that at least tells us what inequality symbol to pick. So I'm going to read through this one more time. So Tori rents a car that has a rental fee of at least $25 plus a daily fee of $18 per day. So if it's at least, that means she's going to be spending at least that much. She may be spending more. So she could be spending that, or she could be spending more depending on the situation. So that means that her total would have to be greater than or equal to. So it can be that much or it's more. That's what at least means, is greater than or equal to. So it means her total is greater than, which means that the open side goes to the T, the total, or equal to 18D plus 25. So altogether, T, her total, is greater than or equal to at least $18 per day plus $25. So moving down to 14.2, this is graphing two variable linear inequalities, which is very similar to graphing like regular two variable equations, where you use a like x and y axis, usually find slope and y-intercept and go from there. So example 1, graphing strict inequalities, which in lesson 13, we talked about like strict versus non-strict. So just as a reminder, strict means just less than or greater than. And then non-strict, you can see in example 2, it could be greater than or equal to or less than or equal to. So it can be like or equal to basically if it's non-strict. So going back to example 1, example 1 is in slope-intercept form, which is y equals mx plus b. So we refer to this form a lot, and I know that like this is an equal sign and this has an inequality. That's not really what we're looking at. We're looking at the order of the terms. So how it has like y first, then a number times x, 1/2 x, and then plus a number at the end. So it's in slope-intercept form. Okay, so we want to figure out what m is. That's a number being multiplied by x. So in this case, m is 1/2. And then b is it's called a constant. It's a number that doesn't have a variable next to it or being multiplied by it. So b is going to be 2 in this case. If it was like a minus 2, that would make b negative, so just be careful with that. And we're just going to treat it like it's a regular equation. So if you want, you could even just like write this as an equation. Y equals 1/2 x plus 2 instead of with the inequality symbol, and start there if the inequality symbol is throwing you off at all. Okay, I'm going to go ahead and erase that down. We'll just focus on the one with the inequality symbol. So remember that b is where you start. So our b is 2. I'm just going to go ahead and write these off to the side. I should have done that before. But m is 1/2. B is 2. This is where we start. So b is the y-intercept, so we go on the y-axis, which that's the one that goes up or down. This is the y, this is the x. So, and then we put a point there. So we'd put a point at 2 on the y-axis. And then our slope tells us how to get to our next point. And remember, we think of slope as rise over run. So since it's positive, I would be going up 1 and then right 2. So remember, rise is like up or down, run is left or right. So I would go up 1 and then over 1, 2, and put my next point, and then 2 points is enough. The only thing we have to do or think about before we actually connect those points is whether or not our inequality is strict or non-strict. So this one is strict. And when we're graphing one variable inequalities, like on a number line, we use an open circle. In this case, we wouldn't draw like a bunch of open circles to connect our line, but we do want to show that it's strict / that it's just less than or greater than. So we do that with a dotted line or a dashed line. Okay, so we'll use it, get like some sort of straight edge, and then connect your points using a dotted or dashed line. But it just definitely should not be solid, because it'll be solid once we get to the non-strict inequalities, and we have to be able to differentiate between the two. Okay, and then here's like, if you're somebody who likes to use like highlighters or different like colors in your notes, like this is your time. So there's one more step that we need to use. Just like how when we had, you don't need to draw this in your notes, but we had like when we were graphing one variable inequalities, for example, say I had a number line and I had to put my point on the number line and then draw my arrow going in one direction or the other, depending on what my inequality was. We have to do that here, but we do it by shading the side of the line, like on the entire graph, basically. So what we need to do to pick what side to shade is we need to pick a point on the graph that is not on the line. So I'm going to leave a note for that because I think that's really important. It's kind of counterintuitive. So and you should add this note as well, pick a point not on the line. And we're doing this to decide where to shade. So pick a point not on the line. That part's really important to decide where to shade. So any point, whichever one's easiest. I like to pick 0, 0 as long as it's not on the line. And in this case, 0, 0 is not on my line, so I'm going to pick it. So I'm going to write that point off to the side, 0, 0. And then what we do with that point is we take it and we put it in the inequality and see if it makes it true. So like this is my x is 0 and then y is also 0, and you could pick a different point and use a different x and y. It's up to you. So we're going to put 0 in for where x is, and then we're going to put 0 in for where y is. So it would be 0 goes in for y is less than 1/2 times 0 for x plus 2. And then we want to see if that makes the inequality true or false. So it'll be 0 and then is less than 1/2 times 0 is also 0 plus 2. because we would like multiply before adding. And then now we can go ahead and add 0 plus 2. So this would be 0 is less than 2, which that's true. So that means that we have to shade the side of the line that included the point that we checked. So we checked 0, 0, which is right here. So we shade this side of the line. And you can just like use a highlighter. You can just like kind of scratch it off if you don't really care what it looks like. I usually just draw like lines like this if I have like a marker or a pencil or something like that. But you should shade the entire, like in this case, lower half of the line, like lower right, I guess. And then that shaded region, it represents what we call a solution set. So I'm going to add a note for that as well. So the shaded region is the solution set. And what that means is that any point, like within this entire region, any point that you could pick on that side of the line would satisfy that inequality, which means that it would make it true. Okay, so moving on to example 2, graphing non-strict inequalities. So our inequality is 6x minus 3y is greater than or equal to 18. This is not in y equals mx plus b form, so we want to put it in that form first. So that means that we want to get y by itself. So I'd have to use inverse operations to cancel out the things around it. So in order to do that, first I would subtract 6x, and then I would have to subtract it from the other side of the inequality as well. So 6x minus 6x, that cancels out. And then I bring down the 3y, but I have to remember to bring down the negative that's in front of it also, because that negative belongs to the 3, and then is greater than or equal to. And then y equals mx plus b, after the equal sign, it has mx first. So I'm going to put the like negative 6x in front. So negative 6x, and then this is a positive 18, so that would turn into a plus 18. And then our goal is to still get y by itself, so now I would have to divide by negative 3, and I would divide everything by negative 3, so both of these terms, negative 6x and 18. So negative 3 divided by negative 3, that cancels out, so I just have y. And then one thing that's really easy to forget but really important to remember is that when you take an inequality, one variable or two, and divide by a negative or multiply by a negative, you have to flip the direction of the sign. So it started off pointing to the right, now it needs to point to the left because I divided by a negative number. And then after that, negative 6 divided by negative 3, that would become a positive 2x. And then 18 divided by negative 3, that's a negative 6. So now it's in the correct form. We can see what m is. M is the number that's being multiplied by x, so that would be 2. And then b is the constant after the number that doesn't have a variable, so b would be negative 6. So m is 2, b is negative 6, so b is where we start, or like begin. Usually b and begin is easier to remember together. So we go to the y-axis, which is the vertical one, and we find negative 6 on it, which is right here. And then we use our slope m to find the next point. We usually think of slope as rise over run, but right now my slope is just 2. It's not a fraction, but I can just put it over 1. So my rise would be 2. My run would be 1. So that means I go up 2 and then right 1. So I would go up 1, 2, and then right 1 and put another point there. And then before we connect the points, we have to look at what type of inequality we have. we have a non-strict, that means that we have like an or equal to, or right here there's a or equal to, so it has that line underneath it. So that means that when we connect our points, there'll be a solid line. If it was a one variable inequality, it would have like a solid dot, like instead of an open circle, we need to use a solid line. And then the next thing we need to do is decide what side to shade on. It's entirely up to you what point you pick. Like I said, I usually pick 0, 0 if it's not on the line. In this case, I want to show you an example of a different point in case you ever wanted to use a different point. So I'm going to pick the point 1, 3. So it could be any point that's not on the line, whatever point you want. I'm going to use 1, 3, which is right here. So 1, 3, I'm going to rewrite my inequality, so it'll be y is less than or equal to 2x minus 6. So I'm going to put 1 in for x and then 3 in for y. It's always x first, then y. So 3 is going to go right here, and then 1 is going to go right here. So it would become 3 is less than or equal to 2 times 1, so, or 1 for x, and then minus 6. So the 3 replaced the y, the 1 replaced the x, and then now we need to simplify, so we would multiply first. So this is 3 is less than or equal to 2 times 1, which is 2, and then minus 6. And then now I can subtract. So 3 is less than or equal to 2 minus 6. 2 minus 6 is negative 4. So next we ask ourselves, okay, is this inequality true or is it false? So 3 is not less than or equal to negative 4. Like, that's not correct. So because it's not correct, that means that we have to shade the side of the line that's opposite of that point. So that point that we checked was right here. It made the inequality not true, so we have to shade the other side. We shade down here. And then that means the entire kind of like, I guess, lower right side of the line, that's all the solution set to this inequality. So that means that any point that's in that shaded region would be a solution to that inequality. One thing I want to add is that when you have like a solid line inequality, like we have, for example, 2, it's a non-strict, and that means that points on the line, for example, like this point right here, 4, 2, that is a solution because the solid line is considering like including those points. Versus if we look at example 1, say we look at the point 4, 4, which is right here, even though that's on the line also, it's not a solution because the dotted line doesn't include points on the line. So I guess, let's see, I'm trying to figure out the best way to write this. So this dotted line, say, does not include points on the line. And then the solid line does. So does include points on the line. And then before we move on to example 3, I just want to add like one little note. Sorry, I like to usually like type these, but for some reason there was a lot more that like came to my mind while doing the notes as opposed to like writing it. So just like put a reminder on your page about like the inequality symbols and if they create a solid or like a dashed line. So if you have less than, or, and this can go anywhere on your page that's going to stick out to you, if you have less than or greater than, it's a dashed line, like example 1 over here. And then if you have less than or greater, or sorry, less than or equal to, or greater than or equal to, it's a solid line, like we just did. Okay, so super, super important. Make sure that you have that somewhere on your page and you can reflect back to it. Okay, so example 3, this is the last one from 14.2. So this is interpreting a graph like from context. This is the same problem that we did at the beginning of 14.1, so it's just we're kind of taking it to a new level. The animal shelter rescues dogs and cats. The shelter can hold up to 125 animals. In 14.1, we created the inequality D plus C is less than or equal to 125 to represent this. The inequality is graphed to the right, and we just want to interpret the solution set. So I'm not really even going to worry about, I might write something down, I don't know, but we'll just talk about it for a second. So the solution set is the shaded region, just like it was up above. So ours is like this whole section right here. That means that any point on the, or within that shaded region satisfy the inequality. But what that means for this problem is that like, so let's just pick a random solution from that set. So let's say this point. That's 60 dogs because it's 60, I'm gonna write, oh, sorry, 60 dogs and then 30 cats. 60 dogs, 30 cats because it was at like 60 on the x-axis, which represented number of dogs, and then it was at 30 on the y-axis, which represented number of cats. So what that means is that's just like one possible combination that works for this shelter. And that makes sense because like it says like it can hold up to 125 animals. So if we have 60 dogs and 30 cats, like we're well within that range. We only have 90 total animals. So everywhere within the shaded region, like that would work and it wouldn't put us past capacity. And then also because this is like less than or equal to, we can include points on the line since it's a solid line. So like let's say it's hard to find like an exact point, but we can say this point right here, that would be like 15 on the dog axis and then 110 on the cat axis. That's a lot of cats. So we could have 15 dogs and 110 cats, which again, that makes sense in the context of this problem because we can have up to 125 animals, and if we have 15 dogs and 110 cats, that's exactly 125, so that's included in the up to. That's our limit. Okay, so biggest thing to pull from this example is just any point that is within the shaded region is a solution. 14.3 is just an extra example of interpreting solution sets from an inequality. So Sam has enough money to purchase 150 yards of fence to make a rectangular enclosure for his property. Write an inequality to find the possible lengths and widths of the enclosure, and then we'll compare the inequality to the graph and interpret the solution set. So we don't need the graph yet. I'm going to go ahead and zoom in so we're not really like focused on it. We just need to start with writing the inequality. So going back to the beginning of the problem, it says that Sam has enough money to purchase up to 150 yards, and he's trying to build a fence to make a rectangular enclosure on his property. So let's draw a picture. So he's trying to create, oh, not turning into a rectangle. He's trying to create a rectangular enclosure on his property, and he has to put a fence around it. So we want to think about, okay, we have a rectangle. We know there's like some formulas for a rectangle. There's area, there's perimeter. Which one do we need to use? So just like kind of a reminder, I know you've done this, probably not for a little while. Area is like all of the area enclosed within the rectangle, and then perimeter is the measurement around the outside of the rectangle. So you want to ask, okay, am I making a perimeter or am I finding the area basically? Since Sam is building a fence around the rectangle or is creating like a fence line in the shape of a rectangle, we need perimeter. I would say if he was like laying down like grass, like sod or something, that would be area because it's like all throughout the rectangle. But we're just trying to build a fence around it, so we just need perimeter. You can find perimeter by adding all four sides, so like length plus width plus length plus width, but there is a formula. So we say perimeter is, instead of like length plus width plus length plus width, we say 2L because there's two L's, and then plus 2W since there's two W's. And then that is equal to the perimeter. Okay, so we're getting closer to be able to write our like actual equation that we need now. So now we just have to incorporate like what is the perimeter going to be, or what can it be? So it says that he has enough money to purchase up to 150 yards. I'm just going to focus on the 150 now. That's what our perimeter can be. So I'm going to replace the 150 with, or sorry, the P with the 150. And then this has to be, it's not, the problem isn't saying that he is going to purchase exactly 150 yards. It says that he has enough money to purchase up to 150 yards. So that's telling us what type of inequality to choose. So this is not something that you automatically have to say like, okay, up to is this inequality. Sometimes you just have to kind of think it through. So up to means that like it can definitely be equal to 150, or it can be anything less than 150. Up to means like we just can't be more than 150. So I'm going to change my equal sign to a less than or equal to. It could be 150 or anything less than that. So the perimeter 2L plus 2W has to be less than or equal to 150. So we have our inequality. That's the inequality that's graphed here on the right. So now I just want to talk about what that solution set means. So it's this entire shaded region. But think about whether, like, does the entire shaded region actually make sense in the context of this problem, or can we kind of narrow it down? So I'm going to say the x-axis is the width and the y-axis is the length. It ends up being the same graph if you switch them though. So can we have a negative length or a negative width? Like, can those values be negative? Is it possible? It's not, because you can't have like a negative distance. So that means that really like the only true solution set for this problem, or at least like in the context of this problem, is the parts where length and width are positive. So it's this whole section right here. And it's not that it's shaded incorrectly. It is shaded correctly, like based on the inequality. It's just with context, some of those answers don't make sense. But now anything within this like green triangle, including points on the line, are solution sets. Or not, sorry, are a part of the solution set. So for example, like this point. That is 40, 20. And if we were to check that, that would be like, okay, the width is 40, the length is 20. Let's just put that into our inequality that we created and see if it works out. It should, just as kind of like a check. So it'd be 2 times the length, which is 2 times 20, plus 2 times the width, which is 2 times 40. And then that should be less than or equal to 150. So 2 times 20 is 40, plus 2 times 40 is 80, is less than or equal to 150. And then 40 plus 80 is 120, which is less than or equal to 150. So that's true. So that point worked. Every point within that solution set should work and should allow him to build that rectangular enclosure.